Online multiplayer is a staple of modern video games. From head-to-head shooters to online racing to collaborative building and exploration games, being able to connect with friends and strangers to play has been a defining change in the video game landscape. However, this feature wasn't always so commonplace. How did online multiplayer become so popular, and how does it work? Some of the earliest video games were two-player games, including early sports games such as Tennis for Two in 1958, early shooter games such as Space War in 1962, and early racing video games such as Astro Race. These video games required players to play on the same device, though, and soon the advent of computer networking enabled a more distance experience. The Dartmouth time-sharing system is a discontinued operating system first developed at Dartmouth College. In 1972, a football video game available on the DTSS gained the capability for head-to-head multiplayer over two networked computers, enabling students anywhere in the college's computation center to compete in a friendly game with each other. In 1975, a handful of video games based on media such as Star Trek and Dungeons & Dragons were released on the University of New Hampshire's DEC System 10. The university's computer system had hundreds of terminals connected via serial lines. By running a program on each computer, students could play games with each other across campus. In 1980, Byte magazine had an article on how to network two Commodore PET computers with a cable in order to play multiplayer games. Flight Simulator 2, released in 1986 for the Atari ST and Commodore Amiga, allowed players to connect via modem or serial cable and fly together in a shared environment. The first popular video game with a LAN version was 1991's Spilker for the Apple Macintosh, which was followed by 1993's Doom, whose first network version allowed 4 simultaneous players. Beginning with the Sega Netlink in 1996, the Game.com console in 1997, and the Sega Dreamcast in 2000, game consoles began to support network gaming over LAN and the Internet. With the growing presence of personal computers and video game consoles in households, games that supported online multiplayer only became more popular. Massively multiplayer online games became an extremely popular genre in the early 2000s, with games like RuneScape and World of Warcraft being played by millions of people daily. Online multiplayer is a staple of video games today, and you can even see community mods created to add multiplayer to games that were not built with it. Online multiplayer has become a core feature of the gaming experience, and the technology that enables it is quite incredible. Let's take a look.
Hey, what up? It's your boy, Spilker, coming at you with some straight-up gameplay of Mario Kart. While we're playing some Mario Kart, I'm going to talk to you about the reason why you're losing all of your online games. Lag. I've had a lot of you guys asking me, Spilker, how are you so good at Mario Kart? The answer is lag, man. I do whatever I can to reduce that. Some of you might not even know what lag is, so I'm going to explain it to you in basic terms. Lag is the time it takes for a signal to travel from your game to the game server and then back to you. And it's important because it affects how responsive and buttery smooth that game is for you. I know you guys ain't the sharpest knives in the drawer here, so we're going to go real deep into that process. Every time you click a button or move your character, your computer sends a signal to the game server. The server then processes that signal, updates the game state, and then sends a new signal back to your computer. This happens dozens, if not hundreds, of times per second. The main problem is that that process isn't instant. It takes time for the signal to travel over the internet from the computer to the game server and then back again. This delay is what we call lag. When you miss your crispy 360 no-scopes on COD, it's because of lag. When you get hit in Smash Bros even though you know you dodged it, it's lag. When you run over a banana in Mario Kart, you guessed it, lag. That's why it's important to keep your lag down. Less lag means more dubs. More dubs means more GGs. In some games, you might notice a little thing called ping. Ping is the delay of the round trip of that signal from your computer to the game server. Ping is measured in milliseconds, and our goal is to keep it as low as possible. The lower your ping, the lower your lag. Now, I know what you're saying right now. Spilker, how do I get rid of this lag? And the answer is, you can't, but you can reduce it. One method is to move closer to the game servers. There's game servers all over the world, and depending on the game you play, it could be close to you, it could be far away. If you want to reduce that lag, you gotta get close. That's why I live beneath the Mario Kart servers. Keeps that lag real low. Another way is to get a better internet connection. The faster the connection, the lower the lag, the more wins you get, the more GGs you have. Well, That's all I've got to say on lag. Now I'm gonna turn it to my guy Toph. He's got some wicked gameplay on his hands.
Thanks for that sweet intro, Spiltron. Now, let's go over how information is passed from our console to the game server and back. So, we'll imagine that we have our laptop, and this laptop isn't any sort of laptop. This is a sweet gaming laptop. Now, our sweet gaming laptop has a MAC address of ABAB-R1J5-ABAB and a private IP address of 10.0.0.10, and we're trying to get game information and data to our favorite game server. Now, how can we do that? First, we're going to send what's called a TCP request, or a transmission control protocol request. Now, this header of the request will have specific information that'll tell the server what kind of connection needs to be established. That information is like source IP, destination IP, source port, and destination port. Source IP is our computer's private IP address, the destination P is the IP of the server, source port is TCP53, and a destination port is a random number generated between a dynamic range that the server will remember for a specified connection between us and for our console and the server. As that TCP request is sent out, we want to hide our private IP, so our router will actually change the source IP to the router's public IP. And then once the TCP request gets to the server, that information is processed, interpreted, and a TCP response is sent in return. That TCP response has all of our opponent's IP addresses, all of our opponent's ports, the transfer protocol that we will use to send game information, and any other established rules and infrastructure of the game. Almost all game servers in the world use what's called user datagram protocol, which is how data is transferred. Once that TCP header is being responded, our router interprets the destination IP with that port, and our router recognizes, if it's port 53 TCP from this destination, from this source IP, then we know this is for this specific sweet gaming laptop, and boom, a TCP handshake has been established. If we were to look at this in a 1v1 situation where we're gaming online with one other person, we will send a user datagram protocol header with a source IP, destination IP, specific ports, and game information that we want to send. So the source IP once again is our private IP, destination IP is the public IP of the router of the console we are playing against, and then any other game information that we want to send. If you're doing a 360 no scope or whatever it may be, that's information that you'd send. Once again, we're hiding our private IP. The server interprets that and then routes it to the router of the opponent. It says, it's on this destination port with this source IP. We know that's from an opponent, and the console gets that information, interprets it, and boom, game data has been transferred. As we keep scaling this up, we can see that we can go on and on and on, adding more consoles, and they're all constantly sending dozens, if not hundreds, requests every minute, every second, transferring game information, updating movement, location, all the other things of what people do when gaming online. So we can see here 3 different consoles all sending UDP requests with that game information, the hiding of the private IPs, the server interprets all those UDP requests, and then for all the corresponding UDP requests that we did not send, we get the UDP responses of all that information. So our sweet gaming laptop sent out the red UDP request, so our router will receive the blue and green UDP responses, interpret that information, and boom, we are gaming online. Next up, we'll hear from Alex and how modern game server infrastructure has changed, and specific things of how they have made this online gaming experience better.
Hey, thanks, Toph. So we've learned about the history of online multiplayer, how to keep lag down, and how game networks work. Now let's talk about how to cheat in online games. How to stop cheaters. Yeah. So first, what are some type of cheats that mess with game networking that we could use if we wanted to cheat? Well, number one, we have wall hacks, fog of war exploits, or anything like that. Having more information than your opponent automatically gives you a huge advantage, so being able to see around corners and through fog can allow you to anticipate your enemy's actions. These cheats rely on the server sending us, the client, too much info. And if we grab some wall hacks, we can get a leg up and clean house. Number 2, packet interception and manipulation. Ever wanted to have unlimited ammo or unlimited health, or press a button to insta-kill without aiming? Well, with the trusted client network model, you can have all three. In games that use this model, each client is playing the game on their local machine and sending updates back and forth between the server on the status of the game. The remote server trusts our machine, the client, to send back accurate info about our game. The thing is, we can hijack those packets our machine is sending to say whatever we want. For example, Ubisoft's The Division used this model and it made online servers a ton of fun. Fellow players took this opportunity to get ahead of other boring players by intercepting and changing the contents of outgoing packets, allowing them to have all the ammo, all the health, and to teleport at will. Now, I guess I should warn you how someone might shut down all our fun. If someone were to try and do that, they would probably use the authoritative and mirrored server model. Essentially what happens in this model is that the client machines send all their inputs, like mouse clicks, movement, etc., to a central server where the actual game is being played. Those inputs are taken and run on the server, and the status of the authoritative server game is mirrored back to each client in real time. The server does not trust the clients at all, and instead runs the game itself to ensure its integrity. Anyways, that's all we've got for you today. Don't forget to like, subscribe, and smash that like button. We'll see you in the next one.